12 joules per second. So you work out the math, and basically took all the energy that human civilization produces and captured that energy for a trillion years or so, or 10 trillion years. That would be about 10 to the 30 seconds. So that starts to get kind of comprehensible, maybe. So the point is it's a lot of energy, right? So it's hard. The message, in case you missed it, is it's hard to destroy the Earth. Okay? So end of the world scenarios that involve the destruction of the Earth, very hard. Even if you slam into the Earth with a Mars-sized object, right? Take Mars and slam it into the Earth, you're not going to destroy the Earth in the sense of it being gone. Okay? You will make a huge mess, and all that matter will come back together, and you'll basically you'll have a planet again in roughly the same place. And in fact, that happened. That's how the moon happened. A Mars-sized object hitting the proto-Earth about 4.6 billion years ago, 4.5 billion years ago, and out of that collision you end up with the Earth and the moon. Right? So it's very hard to destroy the Earth. If you're interested in destroying the Earth, there's a great website. Go to livescience.com, technology, destroy Earth. You can just Google destroy the Earth, and this is the first thing that pops up. And it's very entertaining. It's actually distillation. It's a 10-page website. It's a distillation of a really long website that's even more fun. It goes into great detail about all the possible ways to destroy the Earth. Okay, so, I should add, this will happen eventually. About 5 billion years from now, the sun will exhaust all its hydrogen. And when that happens, the sun expands dramatically and expands to the point where it embraces the orbit of the Earth. And if the Earth is still in that orbit, which there's actually debate about whether it will be by that point, but if it is, then the Earth will be fried to smithereens, and basically this happens. Okay? But that's 5 billion years from now, so don't tell yourself. So another way to think about the end of the world, instead of thinking about literally destroying the Earth, let's think about it more in human terms. We're talking about changing the Earth so that the surface conditions are inhospitable to life, or what we might use a little bit of jargon and call an extinction level event, right, that might extinguish us. Right, this is not a new idea, right? The Bible talks about exactly this, right? The Great Flood is an example of an extinction level event, right? It's not for Noah and, hurting the word of God and hurting all the animals in there, boom, life on Earth except for microbes, fish, and dolphins, right, is gone. And Judeo-Christian tradition, not unique Judeo-Christian tradition, right? There are lots of myths like this in ancient history. So the idea of a catastrophe that somehow makes the Earth's surface inhospitable is an old idea. So what does science have to say about this? Well, it certainly can happen, and Hollywood has dealt with this, of course. The idea of massive meteorite impacts that can cause horrible conditions of the Earth's surface. So 1998 Impact, some of you may remember that movie. Frankly, not quite as fun as 2012, I thought. And this came out at the same time as another movie, Armageddon, which of course had Bruce Willis, who saved the Earth from the thing. Meteorite impact. There's no reason to think that, there was no reason in 1998 to think that we were on the cusp of having something like that happen, and there's no reason now to think we're on the cusp of having something like this happen. We actually monitor near-Earth asteroids. NASA has a fairly vigorous program to catalog all the objects that might someday threaten the Earth, as far as we can tell. At least the ones that are in regular orbits that we can see and then predict when they might potentially hit us. But this is a very real concern. The reason NASA goes out of its way to do this is because we know it's happened before, right? So 65 million years ago, this was once a crazy theory proposed first proposed seriously in 1980 on the basis of some chemical evidence and some rocks and a lot of inference. But since then we've developed a lot of data that convinces 99% of the community that about 65 million years ago, about a 5 to 10 kilometer size asteroid slammed into the Earth near what is now the Yucatan Peninsula and caused massive short-term climate change, massive wildfires, a whole bunch of other things that we think happened, that might have happened, all of which added up to a mass extinction, causing a mass extinction of the dominant life on the planet at that time, the dinosaurs. Extinction dinosaurs. So we know this happened before, and we know that the solar system is a dangerous place. You don't have to look all that far to see that. You look at the surface of the moon, and the cratered surface of the moon is an integrated record of about 4.5 billion years of history of the solar system. On the Earth, radioactive craters get erased by erosion and by plate tectonics, which completely recycles the Earth's surface. So we don't have an integrated record on Earth, but on the moon you've got it. And so the craters on the moon are a record of the impacts over time. We can see from this. We can actually build up statistics to get a feel for how the rate of impact has changed with time. We know the early solar system was a much more dangerous place.
Yeah, I called down there. They didn't
the rate of the frequency of impact is much higher in early solar systems.
Yeah.
And it's settled down after about a million years. There's been a continual
Are you Gretchen by any chance?
And so we can
contacted
allow us to try to predict when the next, extinctional event could happen. And,
Professor Porter sent me from ASU, and I contacted them. And the lady's name was Gretchen. She said it was fine.
Okay.
Yeah, oh yeah, for sure.
ASU
math professor friend of mine, because I do interviews about 2012.
When's the next one? We don't know. It could happen tomorrow. We don't see anything coming, but it's not like it could happen tomorrow, anytime in the next many decades. Maybe it's 100 million years from now. Somewhere in that window, 100 million years, a geologist that's not